All right, functions. We are starting a new unit. It is factoring. Factoring is something that you are going to do for the rest of your mathematical life. It never goes away. You're just constantly factoring. We're just going to change up some things that we do while factoring. So we're going to start with some pretty basic information that you probably already know. So factoring, when we are factoring, that means that we are undoing the product. So something I showed in class is if we have a product of 16, my factors are going to be 1 and 16, 2 and 8, 4 and 4. Oops, it goes all the way down and it goes back, right? So factoring are the numbers that we can divide. It's undoing the multiplying. So that's what we're doing with factoring. So something that I do want you to write down, this is super important, so I want you to hit pause. Write this down. The first step in factoring a polynomial is to find the greatest common factor. That is the number one thing. If you don't know what a greatest common factor is, I have the definition right there. So go ahead and hit pause and write that down. Okay, so we're going to start out with some basic GCF questions. So if I were doing this when I used to teach this in 9th grade in Algebra 1, I used to teach it this way. So I would put this in a box so that I could look at it side by side, and I could see that 7 and 28 have a greatest common factor of 7. And then we could just say, well, if I take a 7 out of here, what do I need to multiply? I need to multiply by k. If I take a 7 here, I need to multiply by a 4, and I end up with 7 times k plus 4. And that's the area model of factoring. That is like the bottom half of a box of diamond. Another way to think about it is we can say the GCF is 7, which is what I did with this box. I can take that from each term. So I could say, I could break it up into its factors. So 7 times k, and then 7, since GCF is the greatest common factor, I do 7 times 4. And then I just write down what I'm left with. So there's the k, and there's the 4. So we get 7 times k plus 4. You always want to check your answer. So back when I did teach Algebra 1, I used to make my students multiply it out to make sure they got the right answer. I think that you guys have gotten beyond that. And so you can just mentally do it. So you can just go, okay, 7 times k, that's 7k. Yep, 7 times 4 is 28. Yep, I got the answer I started with. So that's something you can do. All right. So now we have something a little more complicated. We've got 3 terms. They're pretty big. The degree is 5. So I'm going to go ahead and check for a GCF first. 100m to the 5th minus 50m to the 4th plus 25m cubed. So I put a box around all 3 terms, so I can still do that. There. Notice I'm separating it where the signs go with the term. So I can see that if I look at just the numbers, 100, negative 50, and 25, they all have a factor of 25. And then there's m to the 5th, so that one has 5 m's, but this one only has 4. This one only has 3, so I can take out 3 m's. That's the most I could take out. So then I just need to figure this out. So 25m to the 3rd times 4m squared will give me 100m to the 5th. And then 25m to the 3rd times 8 negative 2 will give me that negative 50, and then I need 1 more m to get m to the 4th. And then 25m cubed times 1 will get me 25m cubed. This is the number one missed thing. We forget to do that 1. So then my answer is 25m cubed times all the stuff written down. So 4m squared minus 2m plus 1. And let's see, does this factor any further? There are no factors of 4m squared that add up to negative 2, so we're totally done. So that's something that you're always going to want to check. You're always going to check to see if you can factor further. That's going to be another difference that's in this class versus the classes that you've done in the past. So I am going to hit pause really quick and erase my board so I can write. I'm going to show you the words that were written down. So if you didn't get all this down, go ahead and hit pause. So again, we can look at this and we can talk about the words. So the numerical part of the GCF is 25. And then we have m to the 4th, m to the 5th, and m to the 3rd. So we're going to use the m with the least exponent, which is m to the third. So we end up with 25m to the third. That is our greatest common factor. So then we can break that up into factors. So that's exactly what we've been doing, and we end up with that. All right. This one is a little bit harder, so go ahead and get this in your notes, and then we're going to break it up. So I'm just going to go like this, and break it up. So I can see 5, 15, and negative 20. Between those, I would get a 5, and I have m to the fourth, m to the fifth, m to the fourth, so I'm going to say m to the fourth, x to the third, x to the sixth, x to the sixth, so x to the third. Then I need to multiply, so I'm going to start, so 5 times m to the fourth to x to the third, that's a 1. 5 times 3 is 15, and I need 1 more m and 3 more x's, and then we get negative 4. I don't need to write anything down for the m. Oops. I get x to the third. And so then my final answer is 5m to the fourth, x to the third times, and then we could just put 1 plus 3m x cubed minus 4x cubed. So again, the numerical part of the GCF is 5, which is what I did. The least exponent that occurs for m is m to the fourth, and the least exponent that occurs for x is x to the third. And so we end up with that GCF that I got right here. And then we broke it up, and that's what we ended up with. So if you have any questions, I'm kind of going through this 2 different ways, 2 different times, so that you can see it twice. Yeah. All right. So now we have this. So this would be the same thing as saying, I don't know, 3x plus 3y. Again, I would break it up like this, because this is a fact, this is a number that's being multiplied by something, and this is a number being multiplied by something. So all of this is a number being multiplied by something, all of this is being multiplied by something. So if I were looking at it this way, I would factor out a 3, and then I have x plus y, right? So we're going to do the same thing here. So I'm going to rewrite this. And I can see right away, after writing it again, I can see what my greatest common factor is. So I put this in a box. So I have this times this plus this times this. So here, I put it in front of the plus sign. So I can see right away that this and this is my greatest common factor. So I'm going to factor out that entire binomial. So now, if I wanted to multiply this by something to get this answer, I would just need to multiply it by a minus 3. It's a minus. And then I would need to multiply a plus 2 times a plus 6. Right? And then we get a final answer of a plus 2 times a minus 3 plus, because the sign comes with it, plus a plus 6, and now I can distribute the positive 1 to get rid of all of the parentheses, so I get a plus 2, I didn't do anything with that. 1 times a is a, 1 times negative 1 is, or I'm sorry, 1 times negative 3 is negative 3, 1 times a is a, so plus a, and 1 times 6 plus 6. Oops, I wrote a. Okay, so now I want to combine like terms, because I can. Whenever you can, you should. So I didn't do anything with that first one. So a plus 2. A plus a is 2a. Negative 3 plus 6 is plus 3. Those don't factor any further, and that is what I end up with. So I've combined my terms. I've checked to see if I can factor any further, and I can't. So that is what we end up with. Alright, so let's do the next one. Let's do y minus 1 times y plus 3 minus y minus 1 plus y plus 3. One of the things that I like about these larger binomial ones, it's a little bit easier to see the factor that's in common. Like I can see that this parenthesis is the same as this parenthesis. So that's going to be my greatest common factor. I don't really have to like think about what numbers are going together, I can just look at these things. And there are no GCF. So I am going to factor out a y minus 1. And to multiply that, I would need to multiply by y plus 3 minus, because the minus right there, and then y plus 4. So now I need to distribute the numbers that are in front of it. So you always want to distribute. So I have y minus 1. And then 1. There's an imaginary 1 right here. So I have 1 times y. So times y plus 3. Then I have negative 1 times y. So minus y. And then negative 1 times negative 4. So we're distributing the negative here. So negative 4. And then I need to combine my like terms. Well, I have y minus y, which is 0. So I have y minus 1. Then I have 0. So 0. And then 3 minus 4 is negative 1. And then that would be my final answer. I can't factor any further, and I'm done. If you have any questions, please let me know. Otherwise, get this in your notes. So again, we're going to want to factor out the greatest common factor, and I can see that this is times something. So now we have a combination of things, right? We've got a term and a binomial plus a term and a binomial. So we have a monomial times a monomial times a binomial. And this binomial right here is squared. So I can see quickly that my greatest common factor is going to be a plus 5. So if I factor out an a plus 5b, I'm going to need to multiply by k squared so that I get that, plus m squared, but then I also need another a plus 5b, and this is different because it's being squared, so I'm going to put the whole thing. So then the last step, just like before, I need to distribute. So I have a plus 5b times k squared. So m squared times a is plus m squared times a, and then m squared times 5b is plus 5m squared b. And then I can't do anything else, so then that's my final answer. So the greatest common factor is the binomial a plus 5b. That's what we figured out. And then I could break it up into those factors. So then, okay, so right here, I know the book gives you brackets. These are just, this is not a time where that matters. These are just parentheses. And then we end up with that, and we're done. So this last example is negative 6r squared plus 5r. This is just a GCF. And how you know when to factor out a positive or a negative. Most of us say just guess. And that's the wrong answer. So if the leading coefficient, and remember your leading coefficient is the number in front of the variable with the highest exponent, so this one would be the leading coefficient, is negative, then you're going to factor out a negative. So we have negative 6r squared, so I can see that this is an r and it's negative, so I'm going to factor out a negative r. So then I can multiply that by 6r, and I do get negative 6r, and then I need to factor out. And then negative 5 will give me a positive 5r. So when the leading coefficient is negative, that's when you factor out a negative. Okay, the next video will be on factoring by grouping, and this was covered in class today.